Hello, 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 everybody. Thank you for joining me once again. Hopefully you're ready to do some more math. We're looking at the 2005 Pascal paper, and we're on question number 24. A positive integer is called a perfect power if it can be written in the form a to the power of b, where a and b are positive integers and b is at least 2. Technically, every positive integer can be written as a to the 1, so they're singling out. They do want it to be a square or a cube or things like that. So we've got examples. 32 is 2 to the 5, 125 is 5 to the 3, that sort of thing. The increasing sequence 2, 3, 5, 6, 7, 10 consists of all positive integers which are not perfect powers. The sum of the squares of the digit of the 1000th number in this sequence is. Okay, 1000th number in this sequence. What are we to do? So it's not a sequence that we can just keep writing out and then eventually we'll get to the 1000th number. No, we're a little stuck. But, how are we going to work this out? So it'd be nice if I could say, perhaps, where a given number that I know is not a perfect power lies in the sequence. That would be something I'd like to be able to do. So, I think I'm going to try that, and then maybe we'll do a little guess and check on the calculator. That's my plan of attack anyway. Is can I get sort of a formula that says, I know 1001 isn't a square or a cube or anything. Where is he on the sequence? And I think what I can do is then say, oh, you're looking at 1001. How many squares are less than that? How many cubes are less than that? How many fourth powers and so on? We'll have to be a little careful because fourth powers and square, there are squares that are also fourth powers, so we don't want to count or get rid of too many things in our count. So we're going to be a little careful, but I think this is the approach. So I think it's going to be sort of inclusion-exclusion a little bit. Okay. So I'll ask myself, where is n in the sequence if I know n is not a perfect power? Okay. That's my immediate goal. So I want to be able to say, oh, 10. I know 10 is not in. 10 is, if we were just listing up the numbers 1 through 10, he'd be the 10th one in the sequence. So I can start with 10. And then how many squares are less than 10? Well, we've got 1 squared is less than 10. 2 squared is less than 10. 3 squared is less than 10, but not 4 squared. And then we also need to get rid of cubes. Well, 1 cubed is less than 10. But I already counted him because he's 1. So this is 1, 4, 9, 1, 8. So I'm not liking, so we'll get rid of that 1 in a moment. 2 cubed, but nothing else. And there's no fourth powers other than 1 again to be less than here. So we'd have 10 minus, let's never count any of the 1s. So 10 minus 2 minus 1. So he should be the 7th position in our new sequence. And 1, 2, 3, 4, 5, 6. He's the 6th. Why? Because we haven't counted at least one of the 1s. So we start with n minus 1. So we minus 1 for all the 1 to the b stuff. All of those are the same number. Then we need to subtract off number of a squareds. Subtract off the number of a cubes. Now when I subtracted off my fourth powers, or if I were to subtract off my fourth powers, they've already been counted by the squares. So don't need to do, I don't need fourth powers. Now, some of these cubes in here might also be square. Like 64 would be in the square list and the cube list. because it's 4 cubed, but it's also 8 squared. So I would need to, I also need to get rid of the fifth powers. So minus the number of a to the 5s. These ones will all be fine because they're primes. Then I need to add on the sixth powers. Okay. If there are any sixth powers, then they were included in both of these lists that I took off. So I've taken the same number off twice and need to add it back on. So that sort of thing is what we need to be looking at. So, what to do? So I think I need, n minus 1 minus plus n minus 1 to the k times the number of a to the b powers less than n, where k equals the number of factors of something. I don't know. So the number of prime factors of n, and we do this sum for all n where you are only a multiple of individual primes, no squares. So no squares divide n. So n's got to be what's called a square-free number. So I think that's what I need to do. And this looks a little too advanced for a grade 9 contest, so I'm probably approaching this the wrong way. Or probably we don't need to think too much about this because we'll never have seventh powers or something like that. Oh! Instead of knocking off all the powers, instead, why don't we... So I think, yeah, as I said, I think this is a little too advanced for a grade 9 contest. I'll come back to this if my new thought fails. But why don't I just do n minus all the unique powers of 1 minus all the powers of 2 that are less than n, minus all the powers of 3 that are less than n, minus all the powers... Well, we don't want powers of 4 because those were already powers of 2, but powers of 5. Minus the powers of 6, minus the powers of... So again, we're going to be doing it with square-free numbers. Because you don't want 4... No, actually... Really anything that's not already a prime power. So powers of 7, you wouldn't want powers of 8, but you could get rid of power. You wouldn't want powers of 9 either, because those would be included in the powers of 3 list, minus the powers of 10 that we get rid of, that sort of thing. So I think this might do it. So, up to what? So, minus all the way up to, minus out the powers of of k, where k is basically square root of n, because if you had anything bigger, then the power that you'd want to subtract, the lowest power that you could subtract off would be k plus 1 squared, but that'd be too big, that sort of thing. Yeah, so let's try it this way. So if I wanted to know where, so we can continue our list a little bit. 2, 3, not 4, 5, 6, 7, not 8 or 9, 10, 11, 12 would be fine, 13 would be fine, 14, 15, 16 is no good, 17 is fine, 18, 19, all of these are fine. So if I want to know where 19 is in the list, so the square root of 19 is about 4-ish, so he's a little bigger than 4. Okay. So I do 19 minus the powers of 1, minus all the powers of 2, so 4, 8, 16, minus all the powers of 3. And we don't need to do powers of 4 because that's already counted, but minus powers of 3, so that'd be 9. There are no more powers of 3. So this would be 18 minus 3 minus 1. So this would be 18 minus 4, so this would be 14. This should be in the 14th position. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So this is working. Alright. So what I want to do is I want to sort of zoom in on what is the 1000th number in our sequence. So let's pick something. Let's, 1001. That's a good starting point. We've obviously removed some things, but let's see, where's 1001? Are we even close, or is this the 500th term in our sequence? I don't know where he is. So the square root of 1000 is about, it's 33, I think. 1001 square root that. So he's a little more than 31. So we're going to do 1001 minus 1 minus the powers of 2 that are less than it. How can I figure out how many powers of 2? Well, if you are familiar with it, and you don't have to be for grade 9, but the log button on your calculator could certainly help. That said, we could just write them out. 4, 8, 16, 32, 64, we're going to keep going here. 128, 256, 512. And then the next one would be 1024. He's not on our list. Powers of 3, we'd have 9, 27, 81. 243, 729. Don't need powers of 4. Powers of 25, 125, 625. So these are actually getting away pretty quickly. Minus the powers of 6. So 36, 216. The next one's 12 something. Powers of 7, so 49, 343. The next one's too big. Minus, so I think it might have been easy to do squares. Subtract the squares, subtract the cubes, that sort of thing. But let's finish this off. So powers of 8 don't matter. Powers of 10, we'd have 100, and we'd have 1,000. And that should be it. Everything else will just be squares. 12 squared, 144, that sort of stuff. So we have 31 squares removed. So 1, 4, 9, 16, 64, 256, 81's a squared, 729's a squared, a square, a square, a square, a square, and then all these other squares. Oh, 625. So that's 31, and then what's left over? Well, we've got 8, 32, 128, 512, 27, 243, 125, 216, 343, 1000. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 others removed as well. So we remove 41 of these guys. So 1001 minus 41. So he should be in the 960th position. Okay. So how does this help us? Well, we only have to go 40 more to get the 1000th. Right? So, 1001. Well, 1002 is not. Neither is 1003. In fact, the next square, do we need the next square? So the next cube would be 1331, 11 cubed. So maybe there's a better way I can explain this. So there's 1 1 below him. There's 30 other squares. There's 10 minus 1, so there's 1/9 power. Or 9 third powers. Alright, so third power, third power, third power, third power, third power, third power, third power. So that's 1, 2, 3 others. Well, that doesn't seem right. Oh, because not all of these third powers. Right. So how many sixth powers? Well, the sixth root of 1000 is basically it's basically 3-ish. So there's 3 sixth powers that we needed to add back on. There were a few fifth powers that we needed to subtract. What was it? 243, or sorry, 243. So 32, 243, and that was it. So there's 2 fifth powers that we needed to add back on. And then there was minus 1 seventh power. And the 8th powers would have been these squares. 9th powers would have been in these 3 powers. 10th powers, well, there's no way, because 2 to the 10 is even bigger. So that's how we get the there's 2 sixth powers. There's 2 to the 6th, 3 to the 6th. I was accidentally counting 1 to the 6th. Okay. So what's the next thing? Well, the next square is 32 squared. So that's 1024. So we'll have to skip over him. So we're at the 960th position. The next cube is, as I say, it's going to be 11 cubed, so 1331. So we'll definitely hit the 1000th term before then. Next fourth power we don't care about. Next fifth power is 5 to the 5. Actually, no, it's 4 to the 5, which is the next fifth power is 4 to the 5, which is 1024, which we're already gonna worry about him. The next sixth power is 4 to the 6. Right, and 4 to the 6 is that's 2 to the 12, so that's way beyond this. That's 4096. So next seventh power is 4 to the 7, that sort of stuff. So we don't need to worry about these. So the 1002 will be the 961st. 1003 will be the 962nd, all the way up to 1023. So that will be the. So add 20 onto this one, so 982nd. We're going to skip over 1024 because he wouldn't be in our list because he's a square. So that would be the 900 and so 1025 would be the 983rd term. The next thing would be 33 squared, and that's well beyond this. I think that's 1089. I think. Yeah, 1089. We're not going to hit that. So we get the 984th, 985th term. So we want to add 15 more to get to the 1000th term. So we'll add 15 here, 1032. So I think 1032 is the 1000th term. I will do a little bit to verify that, but then we want the squares of the digits. So that's 1 plus 0 plus 9 plus 4, so that should be 14. Is 14 even one of the answers? Sum of the squares of the digit. I don't have a 14 here. So that tells me I've done something wrong. Now, what could it be if it should be vaguely around here, shouldn't it? So am I missing, not missing a power of 2 or anything like that. So if it were 1033, we'd have 19. If it were 1034, we'd have 26. Is 26 one of the possibilities? So B26 might be our best bet. But that means I was off by a bit. Why am I off? What have I done wrong? So let's work with 1032 and see if we can't see what his proper place should be. Because I think he's 1000. He should be in the 1000th position, but obviously I'm wrong. So what squares do we have here? So there's 32 squares less than him. So there's let's do it by powers. So powers of 1, we've got, so we need to subtract off 1 for 1. And then we've got 2, 4, 8, 16, 32, 64, 128, 256, 512, 1024. So that's powers of 2. Now powers of 3. We don't need 2 here. We don't need 3 here. We need 9, 27, 81, 234, 729. So that's 3 to the 4, 3 to the 5, 3 to the 6. The next one would be 2187, so that's a no-go. Powers of 4 are already counted. We are going to skip them. So powers of 5, 25, 125, 625. The next one would be about 30-something. Powers of 6, 36. 216, and that'd be 12-something. Powers of 7, so it'd be 49, 343, and then 7 to the 4, which is 2401. So that's out. Powers of 8, well, they're already included here, so we don't need them. Powers of 9, well, they're already included up here, so we don't need them. Powers of 10 would get 100, 1000, and once again, powers of 11, it's just going to be 11 squared, 144, 12 squared, all the way down through. So we'd get 1024 as 32 squared. But he's already on our list, isn't he? So we have 32 squares to take away. One squared, 2 squared, 3 squared, 4 squared, 5 squared, 6 squared, 7 squared, 8 squared, 9 squared, 10 squared, 11 squared, 12 squared, yada yada yada. 32 squared, 16 squared, 27 squared, 25 squared. That's it. So 32 squares go away. So now we're down to, so now we'd be down to 1,000. And we clearly have some more numbers. So I've done something wrong. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 others. So we should be down by 42. So 1032 minus 42. I'm off by 10. So he should be the 990th. What did I do wrong? Oh, I just went up by 5 instead of 15. So my answer should be 1042. Right? Because the next 10 are also not going to be impeded. So he's actually 995. Or sorry, no, he's actually 990, which we just worked out is correct. 10 more to 1042. 1 squared plus 0 squared plus 4 squared plus 2 squared is 1 plus 0 plus 16 plus 4 is 21. Is 21 one of the possibilities? There it is at the end. Okay, so E21. All right. So when we got to 1032, I squared them. Wasn't one of the possibilities, so I realized I made a goof. If I run out of time, I probably would have guessed the next one that worked, which I think was 1034, but that would have been wrong too, actually. So I need to be careful. It's just because I added 5, not 15 towards the end. But there it was. It's an awkward question, in my opinion. I'd like to know if there was a simpler solution. So if you got this a faster way, using sort of grade 9 style math, I'd love to hear it, because it seemed like this was just some bookkeeping, and we sort of guessed at 1001 and worked from there. But yeah, it was kind of awkward. Oh well, that happens every once in a while. It certainly was challenging. Took me a while, so I guess it's good in that sense. We got one more question to go on this contest, question number 25. I'll see you guys for that next time.